This reaction says acetylene and oxygen react to form carbon dioxide and water like this. So we have 2 acetylenes plus 5 oxygens yields 4 CO2 plus 2 H2O. And in General Chemistry 1, you learned about combustion reactions like this. And it says use the chemical equation to answer the questions in the table below. It says suppose 250 millimoles of acetylene and 538 millimoles of oxygen are added to an empty flask. How much acetylene will be in the flask at equilibrium? Well, if you think of this as being a reversible reaction, which is arguable, and I'll explain that in a minute, and you make the reaction go forward in this direction, so you've added only these compounds, well, then the reaction is going to go in the forward direction, meaning you're going to have less of these than you started with. So if you started with 215 millimoles, you are going to go in the forward direction such that you have less than 215 millimoles. Now, what this question is essentially saying is that all reactions are reversible, which is technically true, that all reactions are reversible. Practically speaking, though, if we burn acetylene in a welding torch in the presence of oxygen, we don't expect that the bottle of acetylene will refill itself. First of all, we're not trapping the carbon dioxide and the water, so it's not a closed system. In order for this to be reversible, it has to be a closed system, so these are the only chemicals involved in the system. Secondly, the rate of this reverse reaction may be incredibly slow. So, although technically all reactions are reversible, practically, I'm not sure that it's necessary to consider that. But what Alex is looking for is that all reactions are reversible, and even if you have an incredibly tiny amount of these things, an incredibly tiny amount of the reactants, they'll have so few that they'll no longer react, and the products will eventually reach equilibrium and reform the reactants. So the answer here is some, but a little less. In the opposite case, let's assume we add 230 millimoles of CO2 and 115 millimoles of H2O. How much CO2 will be present in the flask at equilibrium? Well, assuming that you can get this reaction to go to equilibrium, you're going to have less CO2 than you started with, but not none. So you won't completely do the reverse reaction. Again, I'm not a huge fan of exactly what this is getting at from a practical standpoint, but from a technical standpoint, you're going to have some, not none, but less than what you started with, which is the common answer to this question.